So now moving to the second type of analysis, which is the flow simulation plus the self-weight. Before showing the results, let's have a look at the constraints and the loads defined. For the constraints, this room is assumed to be fixed from the bottom here, the highlighted area. And that's where the foundation will be. For the loads, as we can see, we have fluid pressure, we have fluid shear stress in the x direction, fluid shear stress in the y direction, and the fluid shear stress in the z direction. Now these four loads are imported from the results of the flow simulation, and as we can see, they are converted to fluid pressure value and shear stresses values. More than that, we need to define the gravity load, and when defining this load, the program takes into consideration the self-weight of the structure itself. More than that, we have a value of distributed mass of 13,200 kgs, and this represents the mass of the generator itself. Now, after running the analysis, we are interested in three main results. The first one is the stresses, then we are interested in the displacements, and finally, the factor of safety. Starting with the stress. So this deformed shape does not reflect a one-to-one scale of the deformation. This is just for the purpose of the demonstration. As we can see here, the maximum stress we got is 1.6 multiplied by 10 to the power of 8, while the yield strength of ASTM A36 is around 2.5 multiplied by 10 to the power of 8. And as we see, we don't have any red area in this place. If we have a look at the high value, or the highest value, it lies here. And this is a result of a stress concentration resulting from the finite element analysis itself. So basically, this is extremely high, but it's not the case in reality. So, to conclude, when having a wind speed of 120 kilometers per hour, and when the generator is placed inside, we will have these stresses acting on the room. Now, moving to the displacement. The maximum displacement we will have is around 19.7 millimeters. And let's not forget that this value will be present only when having a wind speed of 120 kilometers per hour. And the maximum displacement will be here in this area, as we can see. Finally, move into the factor of safety plot. And the structure, the maximum factor of safety I have here is 2. It's more than 2, but the minimum one is 1.5, and this is our concern. So 1.5 is the minimum factor of safety, and it's only at this point here, which is a result of the nature of the finite element analysis, and it's just a stress concentration. Overall, the structure is safe, and this value doesn't really reflect the actual case. After that, let's talk about lifting analysis.